Hey guys, my name is Abeku Cleland, and today we'll be talking about the primitive and then the reference data type, and then we'll get to know how it is managed and then accessed in the memory. So to begin with, let's get to know what a primitive data type is. So a primitive data type is the basic and then the built-in type in a programming language that holds simple values without any objects or method. So in Java, this includes types like the integer, the boolean, the character, and then the double. So all these data type um, stores a variable which contains a value in the primitive data type, and then its memory, which is the stack. Later we get into the stack and then know what it is. So for now, we are getting to know that the only data types that the primitive data type could take is the integer, the boolean, the character, and then the double. So let's get into the reference data type. So it involves complex structures like the objects which are stored in the heap memory. So rather than containing the data itself, a reference type variable holds a pointer. So with this one, it has a pointer which is connecting or locating or showing that the value is from the stack to the heap. So all what I'm saying later, I'm going to demonstrate it with a diagram for you to understand. So for now, rather than containing the data itself, a reference type variable holds a pointer or reference that indicates the memory address in the heap where it is actually located. So common examples are the arrays, the strings, and objects in languages like Java. So this one we are dealing with Java. So let's get to know the primitive memory management. So primitive data types are basic data types provided by a programming language such as the integers, boolean, double, characters, as we said earlier on. So they represent single values and they are not composed of any other data types. So primitive data types are generally stored in a stack, as we said, a memory area which is designed for static memory allocation. So where you say something is static, it doesn't move. So once it is saved or stored in the stack, the data is not going anywhere. That's why it remains, and then it doesn't change to any other form. And then this region efficiently manages fixed size variables such as the basic data values, allowing quick access and automatic memory management during program execution. Yes, so um, the size of the variable is very fixed. It doesn't change. It's not static. Yeah, it's not. Yeah, it's static. Sorry, and it allows quick access. And then this data type is very efficient and very fast in any way you could use it. So each primary variable holds its actual value in the memory location allocated to it. So for example, let's say int 5 or int x is equal to 5. So as the code says int x equal to 5, in the stacks or in the stack, x is equal to 5 direct. It doesn't change. That's the actual data. But then okay, so later we will go to the reference and then we get to know the difference between the primitive and then the reference data type. So for now, let's get to the accessibility. So accessing a primitive data type is very simple and straightforward. It doesn't take much time, no, and then it's well understood. So the program directly reads and writes the value stored in a stack at the variable's memory address created, which is the stack. So because primitive values are stored directly, operations on them are quick and efficient. So let's say int a is equal to 10. Int a is equal to 10, and then means B is equal to A. Then basically then B is also equal to 10, because A is 10, B is A, and then B is also 10. So it makes sense. So using this data type, your code is going to be very fast for you. It will not waste no much time. So let's get to know the memory management for the reference data type. So a variable of a reference data type does not store the actual object itself. No, it doesn't work like that. But the reference or the pointer to the object's location in the heap. So the stack holds the reference memory address while the heap contains the actual address. So we'll be having a demonstration explaining all this. So in due time we work on that. So reference types are stored in the heap where the memory is used for dynamic allocation during runtime. So a reference or the pointer acts as a middleman. So it's a link, it's a connection between the pointer. No, the pointer itself is a middleman, which is the link between the actual data where it is stored, which is the heap, and then the variable, which is the stack. So this pointer directs from the variable to the data storage spot in the heap memory, as I said. So the heap is a larger and more flexible memory region where objects are allocated dynamically during runtime. Yeah, so let's get to know about the accessibility as well. So accessing a reference type requires following the pointer stored on the stack to find the actual objects in the heap, which is the main location of the reference data type. So this process is somehow slower. Yeah, it's very slow. During our demonstration, you get to know how slow and how fast the primitive data type is compared to this one. So let's say A is equal to, or string A is equal to 0, then string B is equal to A, then B is also equal to what? Hello. But then when B or string B is changed to high, then B is no more hello, but B becomes what? High. So no slide. Let's get this off here. Let's get this off here. Code. Let's say int A equals 5. Int B equals A, then B equals 5. Sorry. So in the stack memory, we have A equals 5, B also equals 5. So let's also do the same for the reference data type. Sorry. Oh. So this will be for the reference, and then as you said, the reference deals with strings and arrays. So in this course we deal with the string. So when string A is equals, let's say name, and string B equals age. In our stack, this will be our stack. this. So in our stack, we know, okay, so in our stack, we get to have A here, and then B here, sorry, and then we get to have the heap, on this one. So A is what? Name. B is what? Age. Then we get to have a pointer. So pointer, as you said, pointing to the heap. This serve as a middleman or a connection man. So pointer from the stack to the heap. Yeah, it makes sense. So as you said, or per our definition, the primitive data type deals with all integers, boolean, and character, and then double. So let's say it's a equals to 5, and then it's b is equal to a, then basically b is equal to 5. So this data is saved at the stack directly. It doesn't need anything, or it doesn't go anywhere. But with the stack, but with the reference data type, when string A is equal to name and then string B is equal to age, the variable goes to the stack, and then the actual data is then stored in a heap. So it needs the pointer to locate its actual destination or its actual storage. That's what the pointer is used for. So this diagram, I think it's going to make more sense. Oh, sorry. Let me make it this way. So this one deals with this one here deals with the primitive data type. This one deals with the reference data type, and this one being the pointer linking between the heap and then the stack, which stores the variables from the code written, and then we have the primitive data type here. Thank you for your time. Thank you very much.